All right, next let's talk about horizontal compression and stretching. So basically bigger, smaller. And we're going to assume that C is a positive number again. So when C is greater than 1, f of Cx compresses. And when C is between 0 and 1, f of Cx stretches. So you may think that this looks backwards, that when you multiply by something big, you get smaller, and then you multiply by something small, you get bigger. Well, that's because what are we affecting here? We are affecting the x-axis, right? It's inside the function, so x values change. And so when x values change, the opposite of what we expect happens. Changing x does the opposite of what we expect. Okay, all right, so here's a new graph here of f of x, and we want to sketch the graph of f of 2x. So what is this telling us to do? I'm just going to draw a line through here. All right, so if this is multiplying by 2, but if we're changing x, it's always the opposite. So instead of multiplying, we're going to divide by 2. And so that's how we're going to change it. So first things first, let's pick our points. Again, you can pick as many or as few as you want, but you want to be able to draw the shape correctly. So typically the end points and any points or dips in the middle are helpful. Okay, so let's write down our x and y values. So we got -6, 6, -2, 1, and 1, 4. All right, so now we just have to transform these points. So again, what's going to change here? We're inside the function, so we're changing x values. That means y is going to stay the same. Just recopy them. And how are we changing our x values? Well, we're dividing x by 2. So our new first x value will be -6 divided by 2. So -3. Okay, and so we'll do the same for -2. X value -1. X value 1/2. All right, so now let's plot these points. So -3 and 6, -1 and 1, and then 1/2 and 4. Oh, sorry, my hair got in the way. All right, so what did we do here? What happened, is that what we expected to happen? Well, we have a 2 inside, so we actually shrink it by 2. So we compress it by 2, so it should just be skinnier. It's the same height and everything, but it's just skinnier. Okay, now let's look at this one. All right, so no instructions here. Besides, for the graph y equals f of x shown below, sketch the graph of the absolute value of f of x. So same questioning, what is changing? Are we changing y or are we changing x? Well, the absolute value is outside of the function, so y is going to change. And how? What does the absolute value do? It makes everything positive. So y will always be positive in our new transformed graph. So we're taking this, which clearly has some negative parts. What's going to happen is these negative parts will just become positive. So we're basically just moving this up above the x-axis. All right, so I'm not going to draw on here. I'm just going to redraw the graph below so we can see. So it looks like it goes down -2, up +2. I'm just trying to kind of match it up as much as possible. Maybe I'll just go to 4. Okay, so what happens with absolute value? So if it's positive, it stays the same. If it's negative, it just becomes positive. Okay, so here, if we start over here at -4, it's positive. So we're just going to stay above, this is what I'm going to, we're going to stay above the x-axis. All right, but then it goes down, but absolute value is going to make it positive. So we're going to stay above. So this graph looks the same, except all of the humps happen above the x-axis for positive y values instead of negative. All right, so check to make sure and go back through to make sure you understand the different types of transformations. Can you tell when we're changing x and y values? Do you know the difference between changing vertically or horizontally? All right, and so feel free to ask me questions about this in class.